What if I told you the universe wasn't supposed to exist? Not the stars, not the planets, not even you. According to the laws of physics, everything should have vanished in a flash of energy, seconds after the Big Bang. But something went wrong, a tiny glitch in reality, and scientists at CERN may have just measured it with unprecedented precision. Deep beneath the border of France and Switzerland lies the most powerful machine ever built, the Large Hadron Collider. Inside this 27-kilometer ring, protons are smashed together at nearly the speed of light, recreating conditions from just moments after the birth of the universe. And what they're searching for is nothing less than the answer to one question: why does anything exist at all? When the universe began 13.8 billion years ago, it should have created equal amounts of matter and antimatter. For every particle of matter, there should have been an identical antimatter twin. And when matter meets antimatter, they annihilate completely. If the universe started perfectly balanced, everything should have destroyed itself, leaving behind nothing but radiation. No atoms, no stars, no life. But that's not what happened. For every billion antimatter particles, there were 1 billion and 1 matter particles. That tiny extra particle, just 1 in a billion, built everything we see today. So the real mystery is this: why was there even a tiny difference? The answer may lie in something called CP violation. CP stands for charge and parity, two fundamental symmetries of nature. For decades, physicists believed the laws of physics treated matter and antimatter almost identically. But experiments began revealing something shocking. They don't behave exactly the same. There is a subtle asymmetry, a flaw in symmetry, a tiny glitch. At CERN, scientists working on the LHCb experiment study particles containing beauty quarks. These exotic particles decay in measurable ways. And what researchers have now confirmed with record-breaking precision is this: antimatter versions of these particles decay slightly differently than matter versions. Not dramatically, but measurably, and statistically undeniable. It's one of the strongest confirmations yet that the universe has a built-in imbalance. This tiny difference, this microscopic preference for matter, may be the reason the universe didn't self-destruct. It may be the reason hydrogen formed, stars ignited, galaxies spun, planets cooled, life emerged. In other words, imperfection created existence. There's still a mystery. Even though CP violation has now been measured with extraordinary accuracy, the amount predicted by the standard model of particle physics is still too small to explain the full imbalance we observe in the universe. Which means there may be new physics waiting to be discovered. Unknown particles, hidden forces, or ancient processes from the first fraction of a second after the Big Bang. This breakthrough doesn't close the case. It makes the mystery even deeper. The universe exists because symmetry was broken, because perfection failed, because nature allowed a tiny imbalance. And somewhere inside that imbalance, we were born. The search continues at CERN, and the next discovery could completely rewrite our understanding of reality. Because sometimes, a tiny glitch is all it takes to create everything.